Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to another session. And today we are talking about a bit of supplementary practice for Unit 2.1, which talks about nature of forces. Okay, so I'm trying to keep those videos short, so I will jump straight into it so we don't waste any time. Hopefully we'll keep it under 10 minutes, maybe even, maybe 15 minutes. Let's go. Okay, so here we've got a bit of an inquiry warm-up. We've got a prediction to make. If you pull on one end of a skateboard, so here we have a skateboard, okay? And if you pull on one end with a force of 10 newtons, and remember newtons is the unit for forces. So if you're wondering what the unit for force is, it's newtons. And then your partner pulls on the other end with a force of 10 newtons, okay? What do you think will happen to the skateboard? Well, simply speaking, nothing. It will not move. It will not move. Why is that? Because the forces are balanced. It will not move as the forces are perfectly balanced, which means they cancel each other out. Okay? Hopefully that makes sense. Next, if you pull on one end of the skateboard with a force of 3 newtons, while your partner pulls on the other end with a force of 6 newtons, what do you think will happen now? Well, now it's a different situation. So we've got one person pulling with 6 newtons, while one person is pulling with 3 newtons. Then obviously we still have an overall of 3 newtons pulling that way. Okay? So now it will go towards the person pulling with 6 newtons. As the net force, remember net force is the overall force, is 3 newtons. So what does that mean? The net force is 3 newtons. Remember, we've got one person who's pulling with 3 and one person who's pulling with 6. Okay, so that means basically it's like this, okay? I want you to imagine it like this. 1, 2, 3, 1, 2, 3, 4, 5, 6. So this will cancel with that, this will cancel with that, this will cancel with that, and we're left with 3 newtons pulling to the left. Okay, so that's what we mean by net force. The overall force that's remaining is going to be 3 newtons. Okay, let's go to number 3. Based on your observations, what can you say about an object at rest pulled in opposite directions by equal forces? It will not move. Not move, as the net force will be 0. It will not move as the net force, the overall force acting on the object, is going to be 0. Right. And then number 4, based on your observations, what can you say about an object at rest pulled in opposite directions by unequal forces? It will move, and to be honest, it will experience acceleration, which means it will experience a change in velocity. It's going to be 0. It will not move to moving. So if you go from 0 to 1 meters per second, that's still considered acceleration. So if you go from not moving to moving, that is acceleration. So we can say it will move, or we can say it will accelerate. Okay? Same thing. Because acceleration is just change in speed or change in direction. So since it will experience a force, it will experience a change in speed. It will either speed up or slow down or change directions. Okay? Right, let's move on. Calculate. You push on a desk with a force of 120 newtons to the right. Okay, so here's the desk. Back to drawings. You know just how much I love doodling. I've always loved doodling, ever since I was a kid. Okay, so you push to the left. Is that left? No, that's right. So you push on the desk with 120 newtons to the right. Here we go, it is to the right. 120 newtons to the right. And your friend pushes on the same desk with a force of 90 newtons to the left. 90 newtons. What is the net force acting on the desk? Well, obviously, the net force acting on the desk is going to be 120 minus 90, which equals 30 newtons to the right. That's what it's going to be. The 90 is going to cancel with the 90 here, and we're left with 30 newtons. Okay? So 100 minus 90, which equals 30. Which makes sense. Right, next, your friend increases her force on the desk by 30 newtons. So now, instead of 90, she is pushing with 120 as well. What happens to the net force on the desk? Okay, the net force on the desk now is going to be 0 newtons. They cancel each other out because they're exactly the same. They're equal and opposite. Is the desk going to move? Is it going to go from 0 to 1 meters per second or 0 to 2 meters per second? The answer is no, it will not move. So big fat no, it will not move, because the forces are equal and opposite, and there's no net force, or the net force equals 0. Net force equals 0. All right, let's move on. Understanding main ideas. Change in object's motion, blah, blah, blah. Okay, so we need to find out what we need to do first. In the Venn diagram, I hope you're pausing the video and doing it yourself before you're looking at my answers. That's the way you're supposed to be doing this. Remember, you pause the video, you attempt to do it, and then you play it and check your answers with my answers. In the Venn diagram, write the phrases listed below to describe unbalanced forces, balanced forces. Write the characteristics shared by unbalanced forces and balanced forces in the area that overlaps. Okay. Change in an object's motion. That is going to be unbalanced forces. Okay. So what I'm going to do is I'm going to label these as A, B, C, D, E, F, and I'm just going to put them in using letters because I don't have a lot of space here. So change in an object's motion, that is definitely, okay, unbalanced forces, right? Okay. Yeah. So what about push or pull? Push or pull, that's going to be shared. Push or pull. Have a direction. All forces have direction, whether they are balanced or unbalanced. So that's shared as well. Do not change an object's motion. That's going to be balanced forces, as the net force is 0. Net force is 0, that's going to be over here as well. Net force is not equal to 0, that's going to be not equal to 0, it's going to be unbalanced forces. Okay, so I hope you got those right. Let's keep going. Building vocabulary. Now, obviously, once again, I need to remind you, do these before you look at my answers. Otherwise, it's not practice, really. Match each term with its definition by writing the letter of the correct definition in the right column on the line beside the term on the left column. All right, so basically, just write the letter over here. Newton. Which one is it? Newton is going to be the SI unit for force, isn't it? So that's going to be A. Force. Which one is force? It's a push or a pull, so that's going to be C. Number 4. Unbalanced forces will not change an object's motion. Unbalanced forces can change an object's motion. And finally, net force is a sum of all forces acting on an object, or the overall force remaining. So that's going to be the answer to that one. Okay, let's move on. And the last sheet, how are we doing with time? We've gone 9 minutes, so not too bad. Hopefully we'll keep it under 15 minutes. If the statement is true, write true. This is the sort of thing you will get in the exam, okay? You'll get that sort of thing where you have to modify the answers, and if it's false, okay? So let's go. My microphone keeps rubbing against my beard, so I'm not sure how clear my voice is. Hopefully it's very clear. Balanced forces do not change the motion of an object. Do we think that's true? In fact, it is true. Balanced forces do not change the motion of an object. Only unbalanced forces do. Forces cause some changes in motion. Some changes? That is false. Forces cause all changes in motion. And that is going to be all changes in motion are caused by forces, whether it's change in direction or change in speed. Slowing down, speeding up, or changing in direction requires force. Number 3 says a net force causes no change in an object's motion. Once again, that's false. It causes a change, I guess. If Manuel exerts a force of 10 newtons to push a desk to the right, at the same time Lynn exerts a force of 15 newtons to push a desk to the left, the desk will move to the left. Yes, it's true. It will move to the left, and the overall net force will be 5 newtons. Number 5 says, when you pull on a window shade, you exert a what force? Oh, no, sorry, a force. That's what they want. Okay? A what can be used to represent the direction and strength of a force. So, an arrow. And if you look back, that's what I actually did. Over here, I'm using arrows. Over here, I'm using arrows. So an arrow can be really beneficial in showing how forces behave. So the strength of a force is measured in newtons. Hopefully you remember that. That's the unit. Newtons. And the symbol looks like this, capital N. The net force determines how and if an object will move or accelerate. Yeah. Okay. When two forces act in opposite directions, the object will accelerate in the same direction as the... that's a good one. We've got two forces acting in opposite directions. The object will accelerate in the same direction as which force? This one or this one? It's going to accelerate in the same force as the greater force. The greater. The bigger of the two. The greater force. A force described by what? Sorry, a force is described by its what and by the direction in which it acts. By its magnitude or by its strength. So in physics we call that the size of the force or the magnitude of the force. By its strength or by the direction in which it acts. Okay, hopefully that makes sense. Hopefully that wasn't too hard. I will see you in the next one.